Hey there, ladies and gentlemen. It is 16.4 homework time. I'm excited. Hope you guys are excited. Let's do this. Okay, so let's see what we got here. So, two swimming pools are draining at constant rates. Big deal. That means we can make equations for them. The draining of the pools begins at the same time. The above ground pool is 72 inches deep and is draining, so the water depth decreases at 4 inches per hour. The in ground pool is 92 inches deep, but it is pumped out, so the water depth is decreasing at 8 inches per hour. Does the water in the two pools ever have the same depth at the same point in time? If so, when does this happen? What's the depth? So here's these guys. We're just solving by tables. That's all this really is. We got to solve by tables. So we're going to be mixing a lot of strategies in, but let's just get into it and let's see what I'm talking about. Okay, so above ground pool. Let's record some information. So let's see. The above ground pool is 72 inches deep and is draining at a rate of 4 inches an hour. So look how I'm going to write this. Minus 4 inches per hour. Over here, this guy over here, the in-ground pool is 92 inches deep and is draining at a depth of 8 inches per hour. And again, we're going minus because she's draining. So here's the deal. We got to fill out this table. But guys, I don't want to do this by hand. That's crazy. It's not difficult to subtract 4 a lot. But what I am going to say is that we have a better way to do this. What I'm saying specifically is that if we have a starting point and we have a rate, we can write an equation. So let's go color code, Mr. Collins. Okay, so what I mean is if I have this value that I know starts at 72 and drains at 4 inches an hour, I can express it through an equation. Likewise over here, I start at 92 and I'm going to lose 8 inches every hour. So in this case, X is going to stand for hours, Y is going to stand for depth. So X be hours, and we're going to let Y be depth. Bellissimo. So let's actually get this into an equation. Now I'm not going to do a table. I'm not going to do this by hand. I'm going to use the technology I have available to me. So here's the two equations. Whoa, boom, the red equation. 72 minus 4 for every hour. The blue equation, 92 subtract 8 for every hour. So let's go to our table and let's check it out. Now, so we have our table at our disposal. Now we're looking straight across. We're looking for numbers. But let's see what they want us to actually do with these numbers. So now I have this table. Okay. Using the variables D for depth in inches and T for the time in minutes, write a rule for each pool. Well, you know what? I actually jumped ahead. We already kind of did that. Let's go back to our rule. So we have 72 minus 4x, and here we have 92 minus 8x, and that's both going to equal y. And so now the question is, will they ever have the same depth at the same time? Well, let's check out this table. Ooh, table. Now, if you're saying, Mr. Collins, I don't have a graphic calculator at home, well, that's okay. You could get one from the media center, but also you have this table. Well, you can fill out my table off this table, So just check it out. Just take a look at it, okay? So if you have to pause the video a few times to fill it out, that's fine. Just do it, all right? So anyway, back to the question. Do these ever have the same depth? What we're looking for are the y's, because in this case, y is depth. I defined it up here. Let y be depth. So we're looking for the same. Well, they're not the same here. That's 72. That's 92. They're not the same here. They're not the same here, here. But we're getting closer. There's that 60, 56, and 60. What's this? 52 and 52. Well, look at that. That's going to be the same depth. So it turns out they are going to have the same depth, and that depth's going to be 52, and it's going to happen at 5 hours. So the depth that it happens is going to be 52 inches, and the pool's going to become empty in 5 hours. Okay, so we're getting that right off our actual screen here. So 5 hours, 52 inches each. So again, not difficult once you're actually to make the table. Now, if you can't make the table in a calculator, you could have done it by hand. It's not a big deal. It's just a matter of subtracting 4 each time. So after 1 hour, take away 4, you end up with 68. After 2 hours, take away 4, you had 64, and so on and so on and so on. But we have this piece of technology to help us. So if you don't have a calculator at home, but you have a computer, talk to me tomorrow, or Monday in class, and I can actually hook you up with this one right here, the one that actually is on your on the computer. So talk to me on Monday, and I'll tell you what you need to bring so you guys can actually take that home with you. Let's take a look at, where'd it go? Oh, there she is. So let's take a look at the second question. Go away, calculator. Steven and Shani are trying to increase their word power. Steven knows 800 word families and learns 4 more each day. Shanley only knows 6,500 word families, but she reads a lot and learns 9 per day. And how many days will Steven and Shani know the same number of word families, and how many will they know from that point? So here's the deal: we need a rule. We definitely need a rule. Because if we're going to make a table like number 6 is asking us to, and we're going to make it in the calculator, we have to type something into the calculator, so we had to have this rule. Moreover, the rule has got to be in y equals mx plus b form, which means what we're really looking for is a starting point b and a slope m, something how it's changing. So let's do Steven first. So Steven knows 800 word families, learns 4 more each day. Well, there's 8,000 word families, 4 more each day. Well, 4 more each day indicates increasing or decreasing. That's going to be our slope. 8,000 word families, that's the starting point. That's what he knows right now. So Steven's equation should look like 4x plus 8,000. Okay. Let's take a look at Shani. So Shani, we need a increase or decrease. That's going to be 9 more each day. So we're looking at y is equal to 9x. And a starting point, 6,500 word families. So that now allows us to actually solve this table or the question by using a table. Now, again, I'm going to use the technology here. I'm not going to kill myself doing this by hand, because that's just crazy. So we have 4x plus the 8,000, and here we have the 9x plus the 6,500. Now, before I hit the table, we should take a second and realize that Shani is going to eventually catch Steven. Now, if you're looking at this, Shani is at a sizable advantage. This guy's at 8,000, she's only at 6,500. How do I know that eventually red will catch blue? Well, it has everything to do with looking right here. So if you're looking at these two numbers, this is how you know the red will catch the blue. In other words, look at this slope. That's 9 and that's 4. She's gaining 9 words when he gains 4. So she will eventually catch him. Like, that is going to happen. Now, it's only a matter of when, so it's a matter of looking at our table. So looking straight across, we're looking for these numbers to be the same. Oh, what are you doing there, guy? Okay, so we're just going to scroll down. Well, we're not there yet. We're not there yet. We're not there yet. So it's definitely not going to be... Oh, man, it's going to take a while. If we can hit the down arrow. Oh, I can. So we're just going to scroll down until we see it. So we're only at 8,000. We're only at 6,900. So we've got quite a ways to go. But something to kind of consider is what these variables actually mean as I'm trying to find an answer here. If we're looking at the x, that's definitely going to be the days in which she's using to read. I mean, it says it right here, 4 more each day. It says it's blocked by the calculator, but that says 9 each day. So what do the y's mean? Well, the y's are the things we don't know, and that's going to be how many words they know. Well, they know 8,000. If they learn 4 each day, how many more are they going to, or how many more are they going to know? So the x in this case is definitely going to be standing for the number of days. The y in this case will be the number of words they know. Oh, here we go. We're getting closer. We're in the 8,000s. Each one is in the 8,000s. Looks like Y2 has quite a bit more to do, though. So I'm going to keep scrolling down, but I'm going to actually pause it to save a little time. And by the magic of video editing, we are back. So I kept scrolling down. Like, I'm still scrolling down here. So one thing you can kind of realize, I'm already at 300 days. Oh, whoa, back it up, Mr. Collins. Look at that. 300. So at 300 days, it looks like they're both going to know 9,200 words. So this should kind of tell you why the technology is so important to use. Now, I'm not saying you couldn't make a table after 300, but why in the world would you want to make a table after 300? So it seems like this table method is really useful, but only useful when you're actually in a place where you can make the tables not by hand, but using technology. Otherwise, I don't know if you guys would have persisted. I don't think I would have persisted making a table after 300 values. But in the end, that's going to be our solution. So the table solution here is the place in the table where we know they're going to be the same value. So that's not going to happen at 299. So look at 299. Steven knows 9,196 words. This guy, Chani, knows 9,191 words. But at 300, they're both knowing exactly 9,200 words. So that's going to be our solution. Now, that's just where I found my solution, which is an important thing to write. But I actually need to write it out. So my solution is going to be x equals 300, which means at 300 days, they both know 9,200 words. Okay. So that's what we're looking for. That's the solution. So again, technology is great, especially when you use it to solve a problem like this. So a little bit different question. Not one we're actually asked to solve, but actually to evaluate mistakes, which is tough. So in this part, you'll read two statements about solutions in linear systems and tables. Each of the provided statements contains a mistake. First, identify and explain the mistake, then make a correct statement based on the tables provided. Okay, so let's see. This guy, Fred, makes these two tables who's solving two equations which we don't know. He says, well, look, I see the y values of 11 in both tables, so the solutions have to be 11. So check it out. He sees 11 right here, and he sees 11 right here. So he's not right. The answer is not 11. So what's the mistake? Well, the mistake is simple. They have to both be 11 at the same time. So when you're looking at these two side by side, this guy's 11 at 4, this guy's 11 at 1. So the mistake is that the answer, the solution, has to be at the same time. And when I mean time, I mean x value. So they have to have the same x value. This goes back to the definition of the system. It's a number y, an x, that solve both equations at the same time. 11 solves it when it's 1. 11 solves it here when it's 4. It's not the same time. So what should we be looking for is in the solution is exactly that, at the same time. So let's check it out. 2, 11, no. 5, 13, no. 8, 15, no. 11, 17, no. 14, 19. So what are we looking at here? Is this possible to solve at the same time? Okay. Well, we have to evaluate. Oh, whoa. Sorry about that, guys. Hey, I'm back. So the question now is, like, how do I actually find the solution? Like, let's make a statement about the solution. That's a fancy way of saying solve the darn thing. So to solve this thing, what we have to do is basically make more of the table. Like, there's not a solution here already. So I'm going to make more of this table, but I'm not going to do it by hand because that's crazy when I have a piece of technology. What I am going to have to figure out is what the equations are if I want to use this. So I need a y-intercept and I'm going to need a slope. Well, the slope here is easy. Here is just going to be a 3. The slope on this side is going to be a 2. I mean, you can do it just by counting. But I need to actually get a y-intercept, and the y-intercept occurs when the value is 0, so I need to count backwards. If I go 3 back from 2, that's going to be a -1. If I go 2 back from 11, that's going to be a 9. So that tells me my two equations. Over here, green guy is going to be modeled by 3x minus 1, and purple guy is going to be 2x plus 9. 2x plus 9. So those are the two equations we're actually dealing with. 3x minus 1 and then 2x plus 9. So when we go to our table, we're just looking at, oh, whoa. I didn't reset it from the last time. Let's start at 0. Let's try that again. So, okay, so we're just looking for these things to be the same, so I'm just going to scroll up or down until I see them. Well, they're getting closer as I'm scrolling down, so they're not the same, they're not the same, they're not the same. Whoa, there it goes. Oh, they're the same. So there is a solution here, but the correct statement we can make is that the solution is not shown. So the solution is not shown. Okay, the answer is actually going to be x equals 10 when y is equal to 29. So there is a solution, it just doesn't happen to be right here. Okay, so again, be careful on your tables. It's common mistakes abound. And then sometimes when you need to find your solution, it's just a matter of making more of your table, not by hand, but sometimes with a calculator. Okay, so we have some more mistakes. Okay, so it looks like Rachel's making a mistake. Rachel makes these two variables to solve a system of equations problem that asks her where lines A and B intersect. She says line A is always above line B, so lines never intersect, they must be parallel. So let's check this out. So let's talk about these two lines, but to talk about them well, guess what? We're going to need equations. So that's the first thing I'm going to do. Let's figure out this slope. That's going to be a -1. The slope over here looks like it's going to be a -2. So counting back, that's going to be 1, that's going to be 0. Let's go back, that's going to be 17, that's going to be 18. So this equation will be y equals -1 plus 18. Counting backwards, so that's 9, 10, 11. 0 is going to be 13. So I'm looking at y equals -2x plus 13. Now, I can tell you right now, these lines are not going to be parallel. In fact, you guys can tell me why also. The slope here is -1, the slope here is -2. Those are not parallel lines. If they're parallel, they're moving at the same rate at the same time and therefore never intersecting. So this tells me Rachel's wrong about her assumption being parallel. But let's get them into our calculator here and we'll see what we actually get. So we have -1x plus 18. And then we have negative 2x plus 13. Okay, so we look at our graph. And we can see that we can't really see what's going on here. So I'm going to blow this up a little bit. I'm going to blow up the window. I'm going to do a negative 30 to 30 all around because I just want to get a nice, clean picture of my graph. There he is. Okay, so there is the first one. And there's the second one. Now this tells me they're definitely not parallel because I can actually see where they intersect. So what can I say about these two tables? Well, I can certainly say this is a solution. Let's go find it. It looks like the answer was going to be negative, so I'm actually going to scroll up. And also you can kind of tell these numbers are getting closer together, and that's what happens before they intersect. And look at that, I did find a solution. We did have a solution here at negative 5, and when they're both 23. So what conclusion can I reasonably draw? Well, the mistake was they're not parallel. And the conclusion I can draw is that the solution is actually going to be x equals negative 5 when y is equal to 23. Okay, so there is a solution. That's the correct assumption you can make. Okay, so solve the following equation for y. In other words, write into y equals form. So this is actually a skill that would be vitally necessary, especially if you considered how much I use the equations in my calculator. So if I wanted to solve this using a calculator, well, I have to get this into y equals form first. Now, this is something we've done. I mean, this is pretty simple. Get y by itself. That means we're going to subtract this 3x. Both sides, of course. So 2y comes straight down. Over here, 24 minus 3x, they're not like terms. I can't do anything with it, but I can bring down both terms. Over here, well, now we have to deal with this times 2. Well, I'll divide by 2, but if I divide one thing by 2, man, I got to divide everything by 2. So what we'll actually have here as a result is the y equals on this side. 24 divided by 2 is 12, and then I'll have a negative 3x over 2. So that's going to be my y equals. So, guys, I hope this helped. Thank you so much for watching. Have a great weekend. We'll see you on Monday. We'll hit the system stuff some more.